college preparation physics, spring force and Hooke's law. So Hooke's law is just Robert Hooke made up the equation that relates to spring force. So that's why, anything related to Hooke's law just means that. And spring force, more importantly, is if you have a spring and it's got a regular length, like a length that if you just sat there by itself, it would be. Well, if you stretch that spring, there's a force inside the spring pulling it back to its regular length, and that's spring force. And I call that its equilibrium or its happy place. The spring wants to be a certain length, and it will exert a force to get back to its length if you stretch it or compress it. Excuse me. So just looking at some constants or some things about springs, if you have a spring, and this would be what I call its happy length, it's sitting here, it's unstretched at its happy length. And that, in this case, that's 0.5 meters. And then you put a weight, in this case, if it's hanging, you put a weight on it. Now, something I'm neglecting here is the weight of the spring itself, but just don't worry about that. You put an extra weight on the end of that spring, it's going to cause it to stretch. And in this case, the stretch should be half a meter, 0.5 meters, because it's going from 50 centimeters, or 0.5 meters to 1 meter. The force that would be experienced by this spring would be in the upward direction, right? So this weight on the spring pulls down, and then the spring force would be up. Where we see springs, there's all over the place, but I just pulled this up so I could show you in the suspension on your car, or in this case a truck. But there's these springs, and this spring, for example, will be somewhat compressed because of the weight of the truck, right? But the reason why the suspension system works is the springs sort of try to get back to their equilibrium length all the time. So we see springs all the time in these applications. So just a few things. Hooke's law is this equation right here, okay? And all it is saying spring force, I'm going to call it FSP, F with a little s and a little p to stand for spring, and it's equal to K, which we don't know yet, X, and X is how much the spring is stretched or compressed. Stretched or squeezed. Excuse me. And this K is different for every spring. It's called the spring constant. So one of the labs you can do really easily, an easy lab to do for this unit would be to investigate Hooke's law, which would be to figure out the spring constant. And it's you'll have the handout, and all you do is follow the directions, and you can find the spring constant for a spring. And that would be one of the labs you can choose. Okay. The big thing is a higher number is a more stiff spring. So comparing the springs in your truck springs, compare that to a slinky or something like that. The slinky might have a K value of, say, 1 Newton per meter, and that's the amount of force to stretch it 1 meter, by the way, where, I don't know, a truck spring might be like a couple thousand newtons per meter, okay? Most of the ones in the classroom are about between 10 and 50 or something like that. Okay, so the relationship, and you should have this in front of you, looks like this. For a given spring, so if you had a spring and you stretched it, and say you stretch it by 0.5 meters, and you could measure how much force that takes to do that. And that's how you do it. And then if you did that for sort of a go along until you stretch it as far as you can, and you measure the force it takes to stretch it, you would make a straight graph, and if you find the slope of that, that would be that K value, the number of newtons per meter, the number of newtons it takes to stretch it 1 meter. So you could also say, for example, the K value in this case would be 20, right? Because that's how much force it takes to stretch it 1 meter. So the relationship, I showed you the proportionality statement before. Spring force is proportional to stretch. That's all that means. So let's just look at an example using Hooke's law. We have the amount that a certain spring is stretched by applying that much force. So that would be the FSP, and that would be the X. And we want to find the spring constant. And so looking at the data we have, X, everything's in meters and newtons, so it's all good. 0.5 meters. FSP is the 10, that's the force. And to find K, here's the original relationship. Well, if you rearrange this relationship, like divide both sides by X, then you would have K is FSP over X. And so it's 20 newtons per meter. Okay, one more example. This one is very common. This is if you have a spring that's being stretched by hanging something off of it. So this is, I call it a vertical spring. It would look like the very first spring I showed you in the picture. And it stretches 1 meter with a mass of 10 kilograms hanging from it, right? And so that mass must relate to a weight, and the weight would be the force pulling down on it, which means that would be your spring force. Let's see the solution. Here's all the data I have. Here's a free body diagram. So if this is my spring, I've got FSP up and I've got gravity down. In this case, the spring force is gravity. They're going to be equal to each other, right? It's the gravity that's causing it to stretch. So Kx, which is FSP, right, is equal to mass times 9.8. So you can find the K value by using this equation, like just by dividing both sides by x to get K by itself, and just substitute in, and it's 98 newtons per meter. Okay, so all I did here, if you have something a vertical spring, you just make the spring force Kx equal to mg, gravity force, and solve for K. So that's all the examples I have. That's spring force, and yeah, it's a nice easy lab. If you want to try the Hooke's Law lab, I'll leave that up to you. And that's it.